So the second part of the talk, and this is not really the second part of the talk. This is the talk that was the background. So this is forecasting monsoon onset and withdrawal in the face of climate change. And I presume, Elena, you will be using some of the background which you have set in the previous talk for this.
For sure.
Go ahead.
Yes. So I'm happy to share with you my finding regarding forecasting monsoon onset and withdrawal in the face of climate change. Before we going to make prediction, we have to answer three very important questions. First, what we are going to predict? Then, where? And then, when will it happen? It should be defined very well, and only in this way it would be possible to, let me say, get result, to make real prediction. So let's see how to treat this problem using the apparatus that I show you in previous lecture. So at the beginning, till people are coming, I'll show you movie. I hope it works. I'll show you movie. It's called Treasure of San Gennaro. And this is strongly related to our topic. But it's a comedy, and the idea is, let me say, a fragment is the following. American gangster in Italy enlists a local gang to help him steal the treasure of Naples patron saint. What happens? Let's see. Actually, let us, I have tell you that nobody still never Treasure of San Gennaro. But this movie in 1960, they tried to solve very big problems that never have been done before and after. So this kind of special temporal problem to find critical point. So this is what we're going to use, trying to solve this kind of problem for monsoon. But before, let me quickly show you a kind of metaphoric way to understand what we're going to do. They were looking for critical point. I will use it like a critical condition. For example, the hay caught fire when candle tipped over. The definition is overbalance of cost to overbalance. The candle is the origin of the problem, a critical element, located in the core of the system. The time when candle tipped over is a critical point. An open window, which gives the direction of flame propagation, is the second element of the system. So we have to find where is the candle located. We have to find where is the window located. And we have to know when when candle tipped over. So how to treat this problem? Actually, it's the very beginning of my research 10 years ago in Monsoon. Start with this citation in a paper. The onset of monsoon is not transition from regime of no rain to rain to rain. It's transition from regime of sporadic rainfall to specially organized and temporary sustained rainfall. This is attract my attention. This is this paper was done by Ramakrishna and Sonone. And when I in 1990. So I decided if I will add to this definition one single word, critical transition. We know that monsoon is critical transition. And once it's critical transition, then I can work with this. Let's go. So finally, we create methodology, nonlinear dynamic of transition to monsoon, predicting onset and withdrawal. The approach is fundamentally different from numerical weather forecast. It's based on the following ground rules. The universal feature of critical transition in monsoon. Next, the new special temporal regularities between tropics and subtropics. And then understanding the essential physical mechanism of nonlinear nature of monsoon arrival and withdrawal allow us to explain first abrupt transition, the abrupt nature, then special temporal heterogeneity and internal variability of monsoon timing. So it's empower us to forecast the onset and withdrawal of monsoon 40 days in advance and 70 days in advance, in respectively. You can find this methodology in this paper, 2016, in this paper. So, critical transition to monsoon. I just remind you the idea what we are talking about. Pre-monsoon, monsoon, critical value of monsoon onset. And this is actually, this period is temperature of monsoon because during monsoon season, temperature going actually in very same value of monsoon is depending on orography of continent, of location where are you observe this phenomenon. So it's appear that actually critical transition in monsoon appear not only in temperature, but also in relative humidity and also outgoing long wave radiation. So this pattern appear in every location of monsoon zone in Indian subcontinent. This is why I'm able to provide you with definition, universal definition based on critical value of 3 atmospheric values. A temperature, relative humidity, outgoing long wave radiation. Here I present universal definition of monsoon onset for every location based on a critical value of 3 atmospheric variables. Temperature, relative humidity, outgoing long wave radiation. OLR is crucial indicator for upcoming monsoon characterizing convective activity, clouds. In very strong clouds that go into the deep to atmosphere, implying scarcity and deep convection clouds. Critical value, temperature, relative humidity, outgoing long wave radiation for every location can be revealed from historical observation using Onset reanalysis. This is a data set that we used in 2016. Now reference will be different, but anyway, you could easily to download the analysis data. And actually, it's very important to understand that when you use some kind of data, you have to know algorithms that how this data produced. The problem is that it could be produced in different way. For example, in reanalysis data, it's the trended data. They focus on a trend, but error entering that time, it was focused on fluctuation. This is why, depending on the on your goal, you need correct that data set to solve the problem. So, and then we could use critical fluctuation. The idea is the idea was the following. Actually, first author of our paper Veronica Stolbova. It was her PhD thesis. She get very high evaluation and successfully defense. 2016. And but before of this paper regarding forecasting of monsoon, she did a lot of network theory approach to analyze data over Indian subcontinent. And this period of time, she found two regions that it's look like a hub with very high values of network measures. And it was questioned how to use this information. And then we discussed, and I proposed, let us use critical fluctuation. So we use surface temperature data 40 days in advance, 70 days in advance, and 1 day in advance of onset of monsoon here in central part of India. So, and we calculate sigma square variance of fluctuation of temperature. And then you can see that 40 days in advance, variance of fluctuation increase by, it's shown by color, increase in this 3 location. 70 days in advance, 2 location. And then 1 day before onset of monsoon here in central part of India, there is a 2 location. That's mean, what does it mean variance of fluctuation increase? We know that critical situation. We know that it's coming. We don't know when yet, but we know that it's coming. And coming in 2 different parts simultaneously. What does it mean? Let us look inside into this 2 squares. So this is Eastern Ghats region, 100 days before onset of monsoon. You can see before onset of monsoon, variance of fluctuation increasing and after that is decreasing. And this region we call North Pakistan. So we also see very strong variance of fluctuation in this period of time. How to explain this feature? So, and this show us early warning only. We're not able to say when it happens. It's early warning. So, what happens? Why here is a so strong fluctuation? You know that actually monsoon going starting from Arabian Sea and reach Kerala. Then it's going to Bay of Bengal. And when flow going to toward to Indian subcontinent, 2 branches of monsoon merge together. You see right here. And this is the core of monsoon, center, critical element of our system that are located in core of monsoon. And 2 branches of monsoon merge for a first time in this period of time. What happens in North Pakistan? Actually, it's anti-cyclone here. It's called western disturbance. From one side, it's cyclone, from another anti-cyclone, and then it's create the monsoon trough along the Himalaya right here. So we find 2 regions. What to do next? Then let us see how it's reflected to another to data in temperature. So again, we analyze data in the end of the May, and then from 2 to 6 June. This is the temperature and wind field, and then we see on the onset of monsoon in Eastern Ghats, temperature here and here equalize. How it possible? And it was really very interesting question. And this happens actually every year. And then let's go further. Then this is the same plot that I showed you before with variance of fluctuation, and below I show you data from 2019, for example, in northern part, in Eastern Ghats and North Pakistan. This curve in red color show temperature over the year in Eastern Ghats region. So then purple line show 5 years average, and then North Pakistan shown by blue and gray data show 5 years average. What we can see? We can see from this two time series actually intersect here and here. And actually why it happens? And this is this intersection happens. And this is the main point. It happens because Eastern Ghats in tropic, but North Pakistan in extratropic. And this is the main discovery. It's very important point to understand how monsoon organized between tropics and subtropics. But let us see what happens between these two intersections. You can see daily precipitation in millimeter, and you see actually rain going between two intersections. So, and with this condition, at the beginning of this second lecture, I told you that first we have to know what we're going to predict. What we're going to predict here? We're going to predict onset of monsoon, that actually intersection of these two time series, and withdrawal of monsoon. This condition between tropic and extratropic. Let's go further. So, and this is the same actually figure, just bigger to show you how it's going on in another year, for example, 2021. And we can see onset of monsoon here and withdrawal of monsoon here. And this is a pre-monsoon. And this is very important, do not confuse it. It's called bogus. That's very bad for farmer when instead of beginning of monsoon, it shows, let me say, earlier like monsoon, but it's bogus. Because after that, you can see it's going to the droughts, and this period of time very difficult for farmers. Okay, what's going then? And if I show you from 2016 example to 2020, you can see temperature, relative humidity always intersect, and it shows us the duration of monsoon season. So this fundamental knowledge, the connection between tropic and extratropic, allow us to go further and to try to predict monsoon onset. And now I'm going to explain you how to briefly methodology to forecast. So we have Eastern Ghats region and we have North Pakistan. On 6th of May 2023, for example, I have to give forecast of onset of monsoon. What I can see? I can see that actually this is the average intersection. This is current intersection. I see that North Pakistan going, temperature in North Pakistan going significantly below average. And Eastern Ghats region also going to below. And then this is a sign for me that monsoon will be delayed. And then I have to analyze condition over Siberia, over polar cycle, over Pacific Ocean, over Indian Ocean, to say how far away we are from monsoon on 6th of May. My prediction was 15th June, to 26th of June. What happens, and this is proof of made by Indian Meteorological Department when they observe onset of monsoon in central part of India from 11 to 23 of June, right here. So what's going, we are going, so it was accurately predicted, actually, onset of monsoon. And then withdrawal of monsoon. Withdrawal of monsoon, you can see, I have to analyze again how temperature between Eastern Ghats and North Pakistan related to each other. What's going on around? The problem is in meteorology, that they always looking at own country, but it's no way to, let me say, find the solution. It's really global process, intertropical convergence ongoing around the global. And all this process has to be taken into account. Finally, my forecast for withdrawal was from 7 to 17 of October in 2023. You can see it here. So 17 of October is 60 of October here, the 20 of October. So between 7 and 17 of October. Those kind of. Actually, and this is forecast from Delhi, the same, in the same way. I'm doing this, and then this is all my forecast from 2016 to 2023. And actually 2024, I'll show you after that. So this is my forecast observation. Actually, it's going very well for central part of India. This was central part of India, and I also have been forecasting 3 years ago Telangana and then Delhi. And then what happens after that? This is actually in our paper. You will find confirmation, not confirmation, actually long-term, how to say, retrospectively, is how success rate of monsoon onset and withdrawal forecast going retrospectively. So in our paper, Veronica calculated 74% of success rate for onset of monsoon and 84% of success rate for withdrawal of monsoon till from whole period of time from 2000 till 2014 here. So then every forecast starting from 2016, I put on this website until now, and you will see how it's related to reality, because I always show IMD observation after result of my forecast. So, and this year, in 2024, I achieved the first ever forecast of monsoon onset date for 22 regions across India, 40 days in advance. And this is state region, meteorological region of India that I forecast. This region corresponds to meteorological subdivision defined by Indian Meteorological Department. The accuracy of 22 forecast was verified using temperature, relative humidity data after fact, which confirms the prediction monsoon onset date. The forecast issued on May 10, 2024 accurately indicated a delayed monsoon in central and northern part of India. For more information, you can see here. You will also find me on LinkedIn. So then 2024, I achieved again first ever forecast monsoon withdrawal date for 10 regions across from Rajasthan to Kerala. IMD never forecast withdrawal. No any agency in the world forecast withdrawal. The accuracy of 10 forecast was verified using observation data from Indian Meteorological Department. You can compare my data with IMD observation. The forecast released on 14 December, 14 days in advance, accurately indicated withdrawal date of monsoon across India. Forecast is unique and no any agency in the world produced such a forecast. Again, you could see this in my page and also in LinkedIn. So I published my forecast. Many different newspaper and news agency contact me every year, and I give them forecast. And then also, it was at the beginning, 2016 in Telangana, and then weather and radar application that distribute my forecast in 1.6 million subscribers in India. So I also forecast in Africa, in South Tanzania, and then I also forecast the beginning and end of ice sea season here in the Sea of Okhotsk. So this is my current, let me say, current state by red line on the map, and then white dots you can see. This is my plan to the future. So in conclusion, the new methodology offers the following key advances. In theoretical background of monsoon, introducing of universal definition of monsoon onset based on critical value of 3 atmospheric variables: temperature, relative humidity, outgoing ultraviolet radiation. Introducing of 2 type of critical transition that I actually it's not in this lecture, but anyway, I found 2 type of critical transition. And then in practical implementation, predicting monsoon timing in central India, Delhi, Telangana, and other 20 states. Prediction date of upcoming monsoon 40 days in advance, that unprecedentedly early, and forecasting withdrawal days 70 days in advance, and it's only one available forecast in India. Methodology has proved successful retrospectively and prospectively since 2016, actually not 14, but it's already more. Forecast of monsoon onset and withdrawal in 8 years in a row were successful. It's open new possibility for local monsoon forecasting and can be extended for other parts of India and around the globe. So thank you very much for your attention. I took 5 minutes more. Thank you very much.
Yeah, can you hear?
Yes, yes, I can hear you.
Yeah. So, okay, first let me ask the audience questions.
The bifurcation theory that you have mentioned earlier in the lecture, how does one apply that to the real statistical analysis of the data that later you
Okay. So this is what I show you. Just bifurcation analysis and critical fluctuation allow me to identify these 2 regions and explain what happens. And once when we found and understand this region, that this region going fluctuation is very high there. That means system going to losing stability. That means critical value of monsoon onset. After that, it's very high fluctuation here. And then it's the trended data, it's not visible here. But if you get data which include fluctuation, you will see how it's growing. So like in a movie, they tried to find out the critical point in a glass. So the same story, you can use fluctuation sigma square of some value of some physical variable to understand what's going on in the system. Actually, when I looking for a data, just looking sample of the data, if I see the sign of critical transition, if it's became interesting for me, then I can work with this. So this is kind of, and now I can work not only temporary, like in our previous history of critical transition. I'm working now, especially in temporary. And this is a big advantage to go further.
I was just asking, can we say something about onset of drought, understanding this dynamics of monsoon? Like we know onset of monsoon, onset and the post-monsoon. So previous years of in India, onset of drought, if you can give some insight of that.
Exactly. Can you see my screen now?
Yes, yes.
So this is my new feature. Already 3 years, I produce dry spell. It's the beginning of monsoon onset, because this is very important for farmers. They don't know how how monsoon come. And actually, in my another topic that it's called different type of transition to monsoon, it's I found that 17% of year actually going via this scheme, via dry spell. 17% of year from 1951 to present, observing dry spell before onset of monsoon. Nobody never forecast this. I give dry spell forecast here between 15th of June to 26th of June. And after that, after post-monsoon, actually now I have many messages or email, even though from farmer. For example, recently some farmer asked me, what is winter going to be? So how much, which temperature we going to expect? I understand them, because they need this kind of special crops, etc., regarding to condition, etc. So I'm trying. So, for example, I reply to this farmer for November and December. More it's not reliable, and then in January I could give, in December I could give him January temperature.
Okay, thank you.
Hi, somewhere you mentioned that as universal criterion for the onset, where three variables like temperature, relative humidity, and OLR should satisfy some critical values for the onset. My question was like, how are these particular three enough to set a date for onset? If because there will there are several other criterias which say about there should be some winds of some particular magnitude for a couple of days, and then there should be rainfall also to set the time of onset.
Correct. You are correct. And this is what exactly meteorologists are doing. The problem is for meteorologists that they have different education than me. I'm physicist. And theory of critical transition, I'm theoretician. And I describe process as I able to describe using critical transition, etc. Indian Meteorological Department, they have different education. At the beginning, they have general physics, and then when they going to master, they actually focus how to use meteorological model to predict not monsoon, but weather. But this is a part of theoretical physics that I explained you today. And this is why I was able to find universal definition, because on every location of monsoon zone, it's show critical transition there. Critical transition in different type, etc. But anyway, it's critical transition. And then this main condition between tropic and extratropic, this is observation. It's not my theory, it's observation. I take data from Eastern Ghats, I take data from North Pakistan, and I see I have to actually estimate when this intersection happens.
Thank you.
Actually, I have a lot of discussion with Indian Meteorological Department. Since 2016, every year I'm going to India and visit many university and meteorological department in Pune and Delhi and medium range weather forecast center in Noida. And also I have been in Chennai many times, so in different parts of India. And they know about my forecast. They actually were very impressed when I showed them 20 region of forecast, never have been done before, and 10 region for withdrawal of monsoon. So we know each other very well, and we update each other with our, let me say, progress.
Thank you.
You're welcome.
Elena, have you tried with the other one, that is our monsoon, northeast?
You mean North Monsoon?
Northeast monsoon, the one which right now.
Neelima, this is, you know, this is a big, let me say, subject. It's another story. Let me say, going globally. In Tanzania, I show you also, I have been in South America and made it there. So it's time will come. Time will come for North, especially when I get this kind of request. What will be with winter, etc. It's regarding to North monsoon. It's really very much connected to Siberia, to northern part of Pacific Ocean, and conditions have to be discovered there. So this kind of.
See, sometimes it rains together in, like right now, for example, places like Bangalore, which we are right now, almost get rain in both the monsoons. So there is some kind of peculiar effect. Do you see any traces of that in the in the southwest monsoon that you have analyzed?
You ask me about northern or south monsoon or or summer monsoon?
No, because there has been unusual rainfall in the last few years, you know.
Last 2 years. Okay, you know, this is depending on when it happens. So my area of expertise, actually onset of monsoon and withdrawal of monsoon. Now, for example, in August, sometimes it happens very heavily and very dangerous, etc. So this is another story. So this is another story, another subject, and it's actually depends on what happens in Indian Ocean. Regarding temperature in Australia, regarding temperature on Africa, and regarding temperature in India. So this is only in this way this kind of happens in summer. And also in winter monsoon, it's also so much, actually this year it was many severe typhoon in Pacific Ocean. But India also get, but not so high like in some part of North China and another this maritime continent countries. I always observe what happens.
Might have something to do. Okay. So thank you so much, Elena. And let's thank the speaker, everyone.
So thank you very much and good luck for your nice event and have a good time in Bangalore. Bye-bye.